Experimental and theoretical probability. So this is dealing with the probability of like how you could figure out like your chances of winning something. So what is the theoretical probability the coin will land on tails? So this is actually like what are the chances of something actually happening? So if you're flipping a coin on tails, well, you have heads and tails. So there's two things that you have. So you have one tails, and there's two things that you have. So the probability that would land on tails would be 1 out of 2. If we wanted to change that to a decimal, you would just divide that in your calculator. So you would do 1 divided by 2, which would be 0.5. If we want to change that to a percentage, you move your decimal 2 places to the left. And so that would be 50%. Okay, so there's lots of ways we could look at that. We could look at it as a fraction. We could look at it as a decimal. We could look at it as a percentage. What's the theoretical probability that would land on heads? Well, heads is our other option. So that would also be 1 out of 2. For C, if the coin is flipped 140 times, how many times would you predict the coin would land on heads? So this would be your experimental probability. So we would predict that it would land 70 out of 140 times. Okay, so we would predict that it would land half of those amount of times. So on D, Johnny flipped a coin 450 times. His results are below. What is the experimental probability? Because we actually did the experiment. So what is the experimental probability that the coin would land on heads? So we look at the total amount of times it landed on heads, which would be 240 out of 450. And if we reduce that fraction, it would be 8 out of 15. Example 2, if we're rolling a die, like a 6-sided die, the probability that would land on a 4, well, there's 1 4 on a 6-sided die, so 1 out of 6 times. What would be the probability that would not be a 2? Well, there's 5 numbers out of 6 that are not a 2. A 3 or a 5, well, that would be 2 out of 6, which will reduce to 1/3. The probability that it would be an odd number, well, you've got a 1, a 3, and a 5. So there's 3 numbers, 3 out of 6 numbers, and that would reduce to 1/2. If the die is rolled 300 times, how many times would you predict a roll of a 1 or a 6? Well, that's 2 out of your 6 numbers, so that's 1/3. And you would want to multiply that 1/3 times 300, which would be 100. Now so that was your all theoretical. Now let's do experimental. So Johnny rolled the die 1,500 times, so that's your actual experiment. His results are below. What's the experimental probability that the die will land on a 4? So that is your 280 out of 1,500 times, and that reduces to 14 over 75. Okay, so now let's look at a spinner. The probability that it will land on a black, well, there's 1 black, and they're all even. See, that didn't mark very well. So since they're all even, that's just 1 out of 4. Probability that's not orange, well, 3 of these colors are not orange, so that would be 3 out of 4. Blue or black, well, 2 of these colors are blue or black, so that would be 2 out of 4. So that would reduce to 1/2. If the spinner is spun 40 times, how many times would you predict to spin of something that is not purple? Well, 3 out of these 4 colors are not purple. So we would do 3/4 times 40, which would end up being 30. So Johnny spins the spinner 60 times. So here's our experiment. His results are below. What's the experimental probability of a spin of orange? So that would be 21 out of 60. Not sure what's going on here. Let's try that again. So 21 out of 60. And if we reduce that, that reduces some crazy stuff going on here. That would reduce to 7. Gracious. 7 out of 20. Which color had an experimental probability that matched its theoretical probability? Well, the theoretical probability is 1/4. So we're looking for a number that reduces to 1/4. Okay? So basically, we're looking for something out of 60 that reduces to 1/4. So the way you want to think about this is what times 4 equals 60? That's the question you want to ask yourself, because that's the number on top that would reduce to 1/4. So what times 4 equals 60? So you could just do 60 divided by 4, and that's going to be your number that goes on top. So 60 divided by 4 would be 15. And then the number that's 15 is your blue. So that would be your answer to F, because 1/4 equals 15 over 60. All right, example 4. So this is the same type of question. It's just designed as multiple choice. Neil tossed a 6-sided die 90 times. The results of his tosses are recorded in the table below. What number had an experimental probability that matched its theoretical probability? So since we're talking about a die, we're looking for something that's going to equal 1/6. And since it's 90 times, we are trying to figure out the number that goes right here. So we work backwards just like we did up here. So remember what we did is we're just doing 90 divided by 6. So 90 divided by 6 is 15. So we're looking for the number that got a 15, which is the 2. So 2 is our answer.